Unreal 5.4 is here and Tessellation is back better than ever, kind of. Nanite Displacement is now officially supported, at least it seems that way, because Epic is now advertising with this feature. The weird thing though is that it's still not enabled by default in the engine. And it's not even a plugin. You might have seen people like use Nanite Displaced Mesh. That's something entirely different. Nanite Tessellation still has to be enabled through adding a couple of lines of options to a INI file, which is highly stupid because, again, Epic at this point is advertising with this feature. So I'm expecting in the future, if you're watching this and Unreal 5.4.1 or even Unreal 5.5 is out, it'll probably at some point actually be enabled by default or be a plugin. But for now, we have to do it a difficult way. So what we're going to do, all that out of the way, we're just going to go into our content browser and at any random asset, we're just going to show that in the Explorer. So we get our directory here for our project, in which we're going to go back into the actual root of the directory. And we'll go into the config files where we find default engine.ini. Here it automatically now sets Nanite.AllowTessellation to being true, which is fantastic. But what it doesn't do, if I take another engine ini from another project of mine, it doesn't actually enable the tessellation itself, because for some reason these are two different lines. So we're going to copy Nanite.Tessellation equals 1 and just paste it into this ini file as well. I'll just post both of these lines in the description and the pinned comment down below this video, so you can just copy and paste them into your file. So once you've done that, we can save this stuff and we can close both of these and we can go back to Unreal Engine, where you might need to restart the editor for it to actually recognize those new settings that you've inputted. So let's do that real quick. And now we will see I, for instance, here have a test mesh, which is now heavily displaced with a, frankly, ridiculous amount of detail. So let's show you how to set that up real quick with making a new material. Let's make a new material, call this Nanite.Tessellation, something like that. And we're going to put it on both that sphere and this plane now. And when we open up this material, we can now see there is an output here for displacement, but by default it is set to being inactive. So we'll have to scroll down a little bit into the Nanite section where we can enable tessellation, which then allows us to actually put a value into here. By default, the displacement of the entire thing is going to be 0.5. If we set that back to 0, nothing will happen. If we set this to like 80, nothing will happen here either, because the preview mesh here is not Nanite enabled. That is a little bit annoying. The best way to change that around is just to have a mesh in the actual world. Make sure that it's Nanite enabled. So if we go to this mesh that we have here and we open it up by double clicking on it, I have Nanite support enabled for this one. But for instance, this sphere that we have here, if I go to it, I don't think this one is Nanite enabled yet. So we want to turn on Nanite support for this static mesh asset, apply changes. And now if we just go and set this side by side, we can kind of work with it that way. This only is really relevant for the displacement map. All the other maps in your material will still preview on this, of course. So if you're just testing out your displacement, this is probably the easiest way to do that. So now we can see if I want to displace this by like 500 units or something like that, and I apply this, it will show on all of the meshes with this material. This is now a lot bigger. This is now displaced upward. This preview just doesn't do anything, which again, this presumably is something that in a future update will be fixed up. But Unreal's advertising with this feature now, so I'm making a video on it. So now the really neat thing is, because we're adding a tessellated geometry through Nanite, relatively performant, as long as it's running off an SSD anyway, but we can pretty much add infinite geometry as long as we have the texture resolution to do so. So if we add a texture sample node here, and I add a very like fine grain noise texture, Let's start with a low-res blurred noise texture just to show you the difference. If I apply this, you can see things are like wavily offsets a little bit, and it's a good way to displace things like maybe water, for instance. And of course we can animate this. Let's get our texture coordinates, add in a panner. We'll pan this in the X direction, and it's panning quite quickly, and it's being a little bit glitchy with the shadows. It seems to be maybe casting shadows on itself or something like that, which is interesting. But now if we switch this out for a much more detailed noise texture, you will see that without adding any actual geometry, we're going to have significantly more. That's way too fast. Let's scroll this like way slower for a moment. You'll be able to see that we have all of this geometry actually being displaced, at least in the GPU. It's not going to displace the geometry physically in the world, so it's not going to alter your collisions at all. And we can pretty much make this as finely detailed as we want as far as geometry goes. So if we take these texture coordinates and we say the UV tiling for this is going to be like 10 and 10, you see how much detail there is in this geometry over here. At this point, this kind of just looks like a grass field, right? If we make this green, so set the base color here to green, we kind of just have a field of grass, which is entirely actually geometry, 100% driven through the material, which could be quite fun and interesting. I don't know if this is how I would make grass, but you get the point. Now, one last thing that I want to talk about real quick is going back into our displacement settings here. If we go back to Nanite, enable tessellation, above that is the displacement settings. We have a magnitude, which is the magnitude of how much one value of displacement will actually displace the newly created geometry in the world. So I think by default this is set to like 4 or 5. I like setting it between 50 and 100, but we can set this to like 5,000 if we wanted to, and this is going to go absolutely nuts. As you can see, that's what it does. Because, oh, we also have this sphere over here that has the same material on it. So yeah, this is kind of nuts. But if we just set this to a value of 1 instead, the effect is going to be super subtle, but it still actually is there. Again, let's set this back to a value of like 100, so it's actually properly visible. And then we have the center point. So you can put negative values into this as well, which will displace it inward. So instead of displacing it out from the face as normal, it will displace it inward. We can actually just show you that by doing a 1 minus real quick. And now you see it's going the other direction. So now it's displacing it downward. The center value here is how far the displacement is at a value of 0. At the default value of 0.5, that means that the middle value of the displacement, so if the displacement is 0, the vertices are going to be in the same position as they would be without this material applied. If we set this to 0, it's going to set that default value to whatever the magnitude is in the positive direction. So if we set this now to 0, you will see that this thing will move up, and all the displacement still will be the exact same, but it's just the center position is going to be offset to being whatever the magnitude is. So if we change the magnitude, you will also see this thing move now. As you can see, the center position is now up 500 units. So those are intrinsically linked to each other. The same holds true the other way. So if we set this to a value of 1, it's going to set the default value, again, when a value of 0 is passed in, to being displaced, in this case, downward, inward from where the original vertices existed. Usually we keep this at 0.5, but it is good to know what this does and that it exists. So have fun with Nanite Tessellation. If we just real quick for fun go into a Nanite visualization and go into like triangles, for instance, you can see there's like a whole bunch of them here. I don't know how well this is going to come through on video, to be honest, but it's a lot of fun and you can still go overboard with it, of course. We are still bound to real-time rendering, but you can do a lot with this. So go ahead and have fun with Nanite Displacement now that it is apparently officially supported, even though you need to jump through a few hoops to enable it. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. And a special thanks to my Cave Digger tier Patreons, Sir J. Thomas,